Let's start. It's only a couple of slides, so I will not even switch to full screen mode. Docker Compose for DevOps. Some of the items I will show will be the same as in the previous lecture or previous presentation. But anyway, so what is it about? Docker. We all know what is it about. One important point at this moment from my side. Sorry? Zoom in. Sure. So let's go full screen. Better, I will read through. So Docker from the website, open platform from distributed application. My other point, it's new, it's cool, and it's overhyped. In the meaning that, yeah, Docker is nice, but let's be honest, everything what Docker does could be done with other tools too. But Docker does it nicely. I am also a fan of Docker, but it's really overhyped as usual with the new technologies. Compose has been already mentioned, and with the Compose you can run complex application with just one command, one configuration, and that's it. You can call it also orchestration for Docker, and it's the same as with Docker. It's new, it's cool, and at this moment it's not yet overhyped. Probably it will be in a couple of months. And DevOps, nobody really knows what does DevOps means. And again, it's new, it's cool, it's also overhyped. Everybody is speaking about it, and nobody really knows what does it mean, or it could mean everything. I chose one important point for DevOps. Infrastructure as a code or everything as a code. With the DevOps is really about the contract between development, operations, testing, and all the different, let's say, groups in the company or application development process. And as this is really, DevOps should be just, let's say, one group or one approach. Everything in not only the code is a code, but also infrastructure, deployment, everything else is a code. And it should be taken care as a code. It means it should be in Git repository or SVN or whatever repository you use. It should be tested and all the other aspects of the development of the application. And that's nice about Docker, that it will help you and it will a little bit push you to this direction. That really your infrastructure or your platforms are code, are well defined. You could run a test on top of it. You could distribute it very easily. And all this, what we are, as many here are developers, what we are used to from development. So let's demo. Okay, I hope that you can see this. Okay, I hope that you can see it at least a little. So I have a simple Django application. Probably a lot of you know Django. It's a Python web framework for the professionals with deadlines. I will just show you what's in place. It's a regular managed PI as a root of the Django. My site contains all of the Django stuff, and on top of it, I have a Docker file and requirements that are being used by the Docker file. So what's in Docker file? Let's have a look. It's simple, from Django on build. Django is, this image is from official Docker library. You could very easily reuse it, and with this one-line command, you have a Django environment in place. And that's all you need, in fact. If you have it, the Django application in the same folder as the Docker file, again, following everything as a code principle, you are good to go. So you could, of course, build it. I will go back to. So Docker build, you could call it whatever you want, and you are building from the folder where you are. The build at this moment will be very fast because all of the dependencies has been downloaded before, and the only way that is happening is that I'm copying the application to the Docker container. So now I can, of course, run what I had actually built. I will go. I will expose the port, so I am able to access it, and I will make it a daemon. I will not name it in any way. And it's running. So that's all what you need for your Django application. Very simple, very trivial, and of course we will continue to improve it. At this moment, this was really about showing how easy it is to create an application that is very well portable, in the meaning, again, DevOps, dev, testing, operations. Now, if the guy from QA team will take this application with a Docker file, everything what's needed is, again, just build the image, or if you have a private repository in your company, just run the image, and the environment is the same for development, testing, production. Really, everything is the same, so there are no let's say, additional contracts, how to provision for the testing, how to provision for production. It's the same. So let's make it a little bit more complicated. I will go to another demo. And again, what I have in place, you can see that there is, again, Docker file, requirements, the same as before. What I'm introducing now is the Docker Compose YAML file, which has been already mentioned. So let's have a look on it. With Compose, you could build, let's say, an application that contains multiple elements. In this case, it's the application itself, I mean web application, Django one, and database that is using the regular Postgres image, again, from the standard Docker repository. I am explicitly exposing ports, and I am creating a link. All of these you could create it with the, let's say, basic Docker commands. This is the way how it's simpler for you, and you could define it more, let's say, declaratively. What's very important is in everything as a code principle. So let's close it. I will first stop the running image. What's in place? Probably is the spread. So I'm stopping the image from before because they are exposing the same port, and of course there will be a clash and I will not be able to access it from outside. I will check whether I have some other image running. Okay, so I'm good to go. As you saw on the previous presentation, I will just run Docker Compose up. I will run it as a daemon again. And now, for example, I haven't had a Postgres image, so I'm downloading the image because I'm running it for the first time. It will take, let's say, maybe a couple of seconds, maybe a minute. And then I will run 2 containers with one command. This could be, as I have separate database, separate application, this could be the production environment. Of course, in production environment, you probably will point Postgres to some volume to really persistent the data and don't have them in the image itself. But all in all, this is, it's very simple. Again, it's the same for the development and for the production. Installing Django, installing some libraries to connect to the Postgres. Copying Django, and I'm good to go. I have now running 2 containers. As you can see, these containers, they are linked together. They have some name. They compose also help you that if you do something with these containers and you stop them and restart them, they are in the same state. This, let's say, stateless, what's against some of the Docker principles, but it could help you very much. So that is, again, if I go to the browser, now it's running. It's running example from the 02, and very easy. Docker Compose has different, of course, different possibilities. Let's go for help. You could build this simple, one of the images in the, let's say, in the compose. You could restart one of the items in the compose. You could restart either the web application or the database by itself. You could stop. You could scale, what I will show later on. So that's it in short. So I will, in the next example, but first I will stop the existing. Stop. Now I am stopping the web. It's Python application, so it takes some time, and then the database will be stopped. And I will move to the other side, other example, where I will just enhance it with the cache. As you can imagine, with the Docker and Compose is very simple. I would like to add the cache there. So I have, again, Docker Compose. I haven't done anything to the Docker file. That's still the same. The source code is still the same, only in the Django application I'm, of course, setting. Sure. I will maybe do this. Great. In the Django application, I'm, of course, setting the, let's say, or telling Django where the database is and where the cache is. And what's good in these settings in Django, I can use the names cache and DB. I don't have to use any internal IPs or anything like that. I can use the names as I call these containers in the compose. To really show you how I mean it is in my side settings. So this is simple Django settings file. If I scroll down to the database, I am really using host DB and regular database engine, and also in caches I am pointing to cache with the name as specified in the compose. Don't say it. And again, what I do is I will run it with one command. I have a new item in the compose memcache, so again I download the image, and second time I will run it, it will be much quicker. Now I haven't run it as a daemon, so I can see the logs files from all of the images together in one console. Again, if I go to web, I will refresh it, and as you can see, it's still example 02. This is not the issue that I don't change the text in the example. There is really 03. What happens is that in the Docker Compose file, I have the item or the container called web. And as this container is already built with the source code from example 2, it is not being rebuilt because it's being reused. There is no change in this container, it's being reused. So multiple options, of course. I can clear my repository to rebuild it, I can force it. I can name it differently. For example, in the Docker Compose, I will name it Web2, and as this is a new name, it will be rebuilt. So let's try, for example, renaming of it. I will stop it. takes the time. I will open Docker Compose. Let's add 2. And I will again start it. Cache DB is the same, nothing changed there. The name of the image for the web application has changed, so it will be created from scratch. Again, I haven't had this as a demo, so I will stay in the console mode, and I have the new, let's say, new source code there. I will now stop it and run it as a demo, and while stopping, in the whole community there is a discussion whether, for example, in this case, source code should be copied to the Docker image or should be external. Both of these approaches has advantages. If it's copied, then it's really following the principle that Docker containers are read-only. It means you will not change it, it's already built in, and you could easily build it from Jenkins, deploy, it's always the same, it's built into the container. If you have it externally, you could easily develop. If you point to other, let's say, volume on your laptop or on your environment, you change the code. In the Python, everything is done on the fly. So as you change, you are developing, and for the development, you are using the same environment as will be used in the production. So both of these approaches has advantages. I shown the baked in. In the next example, I will show how to really use it for development. Before I go there, I will show another nice thing from the Compose, and I will scale it. Let's say my cache nodes are getting crazy, even though in most cases not being cache nodes, but let's scale cache node. It's called cache, so I will just scale cache. I will say I want 2 nodes of it. And Docker Compose will create a new cache, create the links between the containers, and everything is running. It's very simple. Probably in the Django settings, you will need to change some of the configurations, so the Django is working with both of these caches and somehow load balancing. But if I show you the containers, really there are 2 containers for a cache, my cache 2, and probably the last one, my cache 1. In this way, you could easily scale as you want. With again, everything is a code with the same declarative approach for describing what you have in place. There are other issues. One was the configuration of the Django. If you are using some workers, there could be an issue with how to find these new workers, some way of discovering it. There are ways how to do this, whether it is with the Docker itself or by using some features of CoreOS or some other tool set. In the roadmap of Docker Compose, there is an item to be able to scale, so probably they will introduce some way of load balancing in the Docker Compose itself. Not sure how they want to do it, but probably they will find something good. So let's stop it now, and I will move to the other. Stop. To the other example where how you develop the code with the same environment as you have. So as it's stopping, it will take a minute. Let's go down and down. Django example 4, my side. What I have here. No new files, nothing has changed. The change is in the Docker Compose. 1 change is there. One change is that I am using the different Django image. Again, Docker is coming with a lot of out-of-the-box images. some of them are good, but not all of them will suit your use cases. So if you have a different use case, you will create a new one. You could copy the existing one, change something inside. You could create a completely new one. In this case, I have created a new one. As it's a new one and it's not running implicitly in the container, I will run it, let's say, from outside. I will add the volume. It means that the directory where I am right now is mapped to the code directory in the image. And as you can imagine, this code directory is used by the Django in the image. All of the rest is the same. It's DB and the cache. As I said, I have changed the Django. So simple Docker file from the standard Python image to 7. I am creating the code directory, copying there some items, installing Django, or everything would have requirements is Django and library for connection to the Postgres. And I am also adding, in this case, this might not be here at all. I have reused the example from other side. Okay. Don't save anything. So I will just run it. Let's run it as a daemon. As my cache has the same name, again, I scaled previous one. As it's the same name, the scaling of the caches is still in place. So it's a tricky, and sometimes it is doing what you don't want. I have the new Django the container, so I'm again building from scratch. And as it ends,
Can you explicitly set scale in the host file instead of having it used as a set you did external?
Good question. I'm not sure. I don't know. So installing Django, adding code, and at the end I have run it. Again, I will have 4 containers in place, the same memcache and Postgres and the new Django. If I go to the site, I don't have any example number there, but really hello world, I meant index page. So now I will go to my Django application. As I am, let's say, in the development mode, I want to change something in the application itself. To make it simple, I have a really simple view there. So use B, I will just change the hello world. Let's say Prague Docker meetup. And I'm good to go. Now if I go back to application, I will reload and let's say new version of the application is in place. This is very suitable, for example, for production, even though Docker Compose itself is not yet in the state for the production. But if you imagine the production, all the containers are running, the only thing you do is get the new versions from the repository, replace the files on the production servers, and you don't need to change anything. Of course, other aspects, database changes and stuff like that, Django could handle it automatically. Some other frameworks could not handle it automatically. But again, very simple move or very simple development, and also then it could be very simple to move from development to production. And of course, if you are in QA and you get a new version, You really just run the same command and you have exactly the same environment. And it's really the contract between development and operations or development testing operations is well defined and it's part of the application. Everything is a code, everything is part of the application. So,
if Compose isn't production ready at the moment, what strategies are people actually using now to deploy and to automatically scale the different application layers?
as far as I know, they have something like Compose written by themselves. It means that they are calling Docker APIs and linking the containers together. Let's say not manually, but with their tool set. And it also helps, as I said, that in today's state of Docker Compose, there are issues with the, let's say, auto-discovery. If you add a node, how does it work together? You could put there some AJ proxy that automatically detects new nodes. But all of this is not yet finished, so it's up to you to build the right tool set to find it or to do it right. Again, for example, CoreOS could help, as in CoreOS, if you have multiple Docker hosts and you creating containers, you have a single point of truth about all of the containers. So if you name them correctly, you are able to discover that there is a new worker node and distribute the load or the work correspondingly. But a lot of tooling around Docker that could help, definitely. So that's nice, but what's missing? Not a lot, or on the other side, really a lot. Organizations in many cases are not ready for such not only DevOps processes, but for such tooling. Whether is it internal processes or people or tools, it's quite not a big change, but a lot of organizations don't follow the rules or the best practices that are already in place. And therefore, if you introduce Docker there, and Docker is in some cases really strictly following best practices, it will not work together. Not everything is Docker, of course. There is a lot of legacy, and the integrations between legacy and Docker is not yet working very well. A lot of commercial toolset is in place, or even open source. A lot of, especially, let's say, huge companies are trying to introduce Docker in their toolset for the same stuff, whether is it, in this case, HP, CA, IBM, and other companies. But still, the integration between Docker and the rest of the world, it's not ideal. And as I said, Compose is not production ready, and also other tools. For example, Docker has introduced in the last months not only the Compose, but also Machine and Swarm, two other projects for first really booting quickly to Docker, and the other one, it's similar to CoreOS to take care of your Docker host clusters. None of them is yet production ready. So Docker is new. It's hot, but in some cases overhyped and not production ready. As I said, still great, even though overhyped and not production ready, and it's worth to have a look and use it. Even the Compose is being used by smaller companies in production, but with no guarantee. Even Docker is not putting a guarantee on it. So that's it. Thank you. Any questions? Sure.
What's the condition of Compose now? I was using Fig 2 months ago when it was costing, and there were many issues in
Uh, I think that it's moving because probably you know that the Fig or the two guys that has been working on Fig has become the part of the Docker company. It's not really an acquisition because these two guys doesn't have a company, that it was more like their project. So it's part of the Docker, and as Docker announced Compose publicly, it's getting better, but they are saying that it's not production ready and probably will not be in some time. There are other tools. As I said, Docker is a great tool, but none of it, from my perspective, is new. Everything could be done by other tools. Sometimes it's slower, sometimes the approach is a little different. Docker is good at putting it together, marketing it, and make it so simple that everybody wants to use it. That's the advance of Docker.
So I really like the scale command. I didn't know about that, but I think like your application has to know about this scaling, right? Because if you scale like the memcache to like 5 nodes, your application has to know like, or there are 5 nodes. So, and also
yes.
How does the port mapping works?
Yeah, your application have to know about it. In the case of the ports, I intentionally scaled cache because cache is not exposing any external port. If I will scale web in the state I have it now, it will fail because it will expose the same port as the other node. So these are the stuff that is not yet, let's say, being well done in a Compose, or you need some load balancer before it that is really smart and knows about the internals of the Compose. Different ways how to do this. Mostly the workers or the caches or whatever you scale are very independent, and as I said, you need some way for discovery. Other group at HP is using CoreOS because this is one very good thing there. All of the nodes are synchronized, synchronized in a way that on every node you have an information about all other containers in the cluster. And if, for example, web nodes need to communicate to any of the worker or cache nodes, they just ask to list all of the workers and pick one, or pick one for the longer time. But it's not solved yet, to answer your question.
Yeah, and can I elaborate a little bit? Have you tried scaling like database to have like master slave and like 5 slaves or something?
That's something I haven't tried, but what I know from the other toolset that is quite similar to Compose is that in most cases this toolset will not solve it for you. If you are scaling database, you need to know what you are doing.
Okay,
it's
thanks.
difficult. Okay, thank you too. And if you want to play with what I have just shown, it's on GitHub with a couple of sentences about how to run it. The URL is long, but if you look for Docker Compose in DevOps, probably you will find it, and you could play with it. Thanks.